example 2D, the expression that we are trying to convert to an equivalent trigonometric expression is the sine of theta minus cosine theta, that quantity times the cosecant of theta plus the secant of theta. All right, so again, our goal is to turn this into an equivalent trigonometric expression that has no fractions, and all of the arguments are theta, can't have a negative theta, okay? Your answer can have any of the 6 trigonometric functions in it, okay? The directions tell you to convert everything to sine and cosine. To do this, again, that is not a requirement. It is one of the ways you can turn this into an equivalent trigonometric expression, but it is not necessary. Look at this. What does your gut say to do? Okay. My first reaction is to multiply this out. Okay, so that's what I'm going to do. Okay, so you have to use FOIL here. Okay, so we need to multiply the first terms together. Okay, so this is going to be sine of theta times the cosecant of theta. Okay, then multiply the outer terms together. So this is going to be sine theta times secant of theta. So we're going to get plus the sine of theta times the secant of theta. Then I need to do the inner terms. So this is going to be negative cosine of theta times the cosecant of theta. So write that down, minus the cosine of theta times the cosecant of theta. And then finally the last terms. So this is going to be negative cosine of theta times the secant of theta. So this is going to be minus cosine of theta times the secant of theta. Okay, so we keep going here. This looks like a lot. We can definitely try to simplify this down. Okay. All right. At this point, I'm going to convert everything to sines and cosines. Okay. So if I do this, I know that this is going to be sine of theta times the cosecant of theta is 1 over the sine of theta. Okay. Moving on to the next term, this is going to be plus the sine of theta times the secant of theta, that's 1 over the cosine of theta. And then the green part, this is going to be minus cosine of theta times the cosecant of theta, that's 1 over the sine of theta. And then the last term here, it will turn over to be minus cosine of theta times the secant of theta, that's 1 over the cosine of theta. Okay? So we end up with fractions. Okay, so we're going to have to eliminate those. Let's see what happens in this first term here. If we're going back to the blue term, we have sine, if you multiply across the top and across the bottom, because remember sine of theta is really a fraction. Okay, all of these guys are really fractions. Okay, if you multiply across the top and across the bottom, you're going to get cancellation. Okay, you will see that this sine theta will cancel with this sine theta, so that's going to leave us with just 1. Okay, in the next term, if you multiply across the top and across the bottom, you're going to be left with sine of theta over the cosine of theta. Okay, looking at the green piece, okay, we're going to have a subtraction sign, multiply across the top and across the bottom. We're going to be left with cosine of theta over the sine of theta. And then in the last term, the black piece, we have minus, multiply across the top and across the bottom. You'll have a cosine in the top that will cancel with a cosine in the bottom. Okay, that is going to turn into a 1, a minus 1. Okay, don't think that nothing is left. It's understood to be 1 over 1, which is 1. Okay. All right, so this is what we're left with. Okay, the great thing here is now I see that the 1's disappear. I have a 1 minus 1. Those guys are going to cancel in the next step. Okay, and I can easily eliminate the fractions because I know sine over cosine, that's going to be the tangent of theta. And then we're going to have a minus sign in the middle. And then the cosine of theta over the sine of theta, that's just going to be the cotangent of theta. Okay, we are done. This is the final answer. Okay, we can have any of the 6 trigonometric functions in our answer, so it's okay to have a tangent and a cotangent. There are no fractions, and our arguments are theta, not negative theta. Okay, all right, let's try another one. Okay, moving on to part E. Okay, the expression that we want to transform into an equivalent trigonometric expression is 1 plus the tangent squared of theta over 1 minus the secant squared of theta. Okay, all of our arguments are positive theta, so that's great. You know, we have a fraction, we are going to have to get rid of that. Okay, again, the directions say convert everything to sine and cosine. Don't bother here because when you look at this, it screams Pythagorean identities. Okay, so if we look at the top here, 1 plus the tangent squared of theta, okay, go back to page 1, 1 plus the tangent squared of theta, that's this guy, okay, that's this Pythagorean identity, so the top becomes the secant squared of theta. Okay, so I'm going to go back and write that out. The top is going to be the secant squared of theta over the bottom 1 minus secant squared of theta. That is basically the same Pythagorean identity, just used in a different way. Okay, so let's come over here. Okay, actually, I'll do it on this page. Okay, I'm just going to rewrite this guy and kind of manipulate it. Okay, I'm going to go out to the side to do this. Okay, I know that the Pythagorean identity that we're using here is that tangent squared of theta plus 1 is equal to the secant squared of theta. Okay, well, look what's in the denominator. We have 1 minus secant squared theta. So I'm going to take this identity and I'm going to move the secant squared over. Okay, that's going to give me on the left side, I'm going to get that 1 minus secant squared theta. That's what I'm looking for. Okay, so this is going to tell me that tangent squared of theta plus 1 minus the secant squared of theta is equal to 0. Okay, on the right, the secant squared thetas subtract out, you're left with nothing. Okay, so to get an exact match on the denominator, I need to move the tangent squared of theta over. Okay, so since it's positive, I'm going to subtract it over. So now this tells me that the denominator, which is 1 minus the secant squared of theta, that is equivalent to negative tangent squared of theta. Okay, so I'm going to put that, I'm going to make that replacement. 1 minus secant squared of theta is the same thing as negative tangent squared of theta. Okay, all right, so now we have to keep going because we have a fraction. Okay, so at this point, I'm going to change everything to sines and cosines and see where that takes me. Okay, that's always the plan. If you can't figure out where to go, change everything to sines and cosines and see what happens. Okay, the numerator is secant squared theta. Okay, that is going to be 1 over the cosine squared of theta. The denominator is going to be negative tangent squared theta. So we're going to leave the minus sign out front. Tangent squared theta will convert to sine squared theta over the cosine squared of theta. Okay, you are dividing two fractions, so go ahead and do that. You're going to leave the top fraction alone. You're going to change division and multiplication. You're going to flip the bottom fraction, so it's going to become negative cosine squared theta over sine squared theta. Okay, we're now multiplying two fractions. You need to multiply across the top and across the bottom. You see that there's a cosine squared theta in the top. There's one in the bottom. Those guys cancel. That leaves you with negative 1 over the sine squared of theta. Okay, and this is still a fraction, so we have to get rid of it. Okay, but we know that 1 over the sine squared of theta is cosecant squared of theta. Okay, and the negative sign has to stay out front. Okay, we are done. This is the answer. Okay, this expression, 1 plus the tangent squared of theta over 1 minus the secant squared of theta, it is equivalent to the negative cosecant squared of theta. All right, let's try one more. Okay, and then I think you'll be perfectly set up for verifying identities. Okay, our expression in part F is negative secant squared of negative theta plus sine squared of negative theta plus the cosine squared of negative theta. Okay, good news is we don't have any fractions, but we do need to get rid of the negative arguments here. Okay, so I'm going to write this out. Okay, remember, the more you write, the less likely you are to make a mistake. Okay, I'm going to deal with the negative secant squared of negative theta first. Okay, this negative sign is going to live out front. Okay, this is the same thing as negative, and this is the secant of negative theta times the secant of negative theta. Okay, if you're squaring secant squared of negative theta, that means you're multiplying it by itself. Okay, then we're going to have a plus sign. We're adding sine squared of negative theta. That means we're taking the sine of negative theta and multiplying it by itself. Okay, and then we're adding cosine squared of negative theta. So that means we're taking the cosine of negative theta and multiplying it by itself. Okay, I'm just trying to deal with the negative argument right now. Okay, so let's see what happens. Let's go back to the secant piece. Okay, this minus sign is just hanging out front. Okay, it's not going anywhere. Okay, we know that secant is an even function. So that means the negative sign gets absorbed. Okay, inside the brackets, secant of negative theta is the same thing as secant of theta. So this first secant turns into secant of theta. The second one does as well. So it's going to be secant theta times secant theta. The negative argument is gone. Okay. In the next part, we're adding. Okay. Sign is odd. That means the negative sign will come out. Okay. In this first sign, sine of negative theta, that's the same thing as negative sine of theta. Okay, so we're going to be multiplying here by another sine of negative theta, which is equivalent to negative sine of theta. Okay, then we're adding, okay, the cosines here. Cosine is an even function, so the negative sign gets absorbed. The cosine of negative theta is the same thing as the cosine of theta. Cosine of negative theta is the same thing as cosine of theta. Okay, negative arguments are gone. All right, so let's continue. Back to the secants. This negative sign stays out front. Secant theta times secant theta is secant squared theta. And then moving on to the middle term here, we're adding. Negative times negative will turn positive. Okay, so let me put that here. Negative times negative will turn positive. Sine theta times sine theta is going to be sine squared theta. And then we're adding the cosine pieces. Cosine theta times cosine theta is cosine squared theta. Okay, so this is what we're left with. Going into the last piece, you see sine squared theta plus cosine squared theta. By the Pythagorean identity, that's 1. Okay, so if we're adding sine squared theta plus cosine squared theta, we're really adding 1. Okay, there's nothing I'm going to do to the secant right now. Okay, so that brings us to this step. Okay, we can rearrange terms. This is positive 1 minus secant squared theta. Okay, and we know from going above here, okay, 1 minus secant squared theta, okay, is the same thing as negative tangent squared theta. Okay, so this whole thing turns into the negative tangent squared of theta. That's how this guy simplifies. Okay, or not necessarily simplifies, but this is how you rewrite it as an equivalent trigonometric expression. Okay, we know we're done. Okay, there are no fractions in the answer. There's no negative argument. Okay, and we've essentially, quote, simplified it. Okay, it looks much simpler than what we started with. Okay, all right, so doing this practice, like I said, of taking a trigonometric expression and converting it using fundamental identities and algebra into something trigonometrically equivalent, this is setting the stage for the next section. Okay, the next section is going to be verifying or establishing trigonometric identities. You should have learned this in your trig class, so this should be a review. Okay, so again, this is setting you up to take an equation. You will have an equal sign now, and you're going to have to prove that the statement is true for every instance of the variable. Okay, so what that will entail is starting with one side of the equation, using the fundamental identities and algebra to come up with the other side of the equation. Okay, and that shows that one side is always equal to the other, no matter what the value of the variable is.